Morning, folks. Hope you enjoyed the keynote speech. Today, we are going to talk about data, and specifically data in financial services industry. Before I go into the agenda, let me introduce myself. I am Dhimant. I've been a technology manager with Goldman Sachs in Consumer and Wealth Management Division. I work out of Salt Lake City, and I'm passionate about data, passionate about building scalable products that utilize data and data products. Another passion of mine is technology operations. So this is who I am, and let's get into the conversation today, the discussion today. Basically, what I'm going to talk about is building blocks of data, what we consider as the reference data or building blocks of data for financial services industry. Then we'll go into the challenges. Zach, can you hear me okay?
That's better.
Okay, cool. All right, I'll go back to the agenda. So we talked about building blocks of data. And we'll go into the challenges, and this might not be specifically to financial services industry, it might be other industries as well, healthcare, insurance, they might be facing similar challenge. And then what technologies we use. So basic idea is to share the information and also talk about some of the challenges which might be common or which might be experienced in some different way in different industries, and kind of correlate our experience and see if you are passionate about it, if you are interested in it, please reach out to us. That's the goal of this conversation. So let's dive into the first topic, which is building blocks of data. So my conversation is going to be focused more around wealth management and private wealth management specifically. We deal with highly successful clients who have sizable investing network that we reach out to. And then, these could be entrepreneurs, this could be individuals, this could be family offices, trust, it could be a number of clients. So there is a prospecting process where folks from Goldman, they meet with a prospect and then they pitch in that what value Goldman Sachs can add for them. And then let's assume they become our clients. So when they become our clients, we do their KYC checks, source of wealth to make sure all the regulations are met, and then they come in and open accounts with us. This could be individual accounts, joint accounts, trust, IRAs, Roth, corporate accounts, you name it. So and then as part of the account opening process, they also sign regulatory disclosures, and all the regulatory information is shared with the client. They sign in, let's say the accounts are fully open and ready to be funded. So client sends either money to these accounts, wires in, or brings in assets from other firms or other brokers. So that's how you initialize or fund the account via this type of transactions. So now let's say you have investable asset in these accounts and you start trading. You buy 100 shares of company XYZ. So these are all types of transactions. You buy transactions, you buy bonds, they pay you interest, dividends, all those type of activity is considered as a transaction. And when you have, let's say you bought 100 shares of XYZ, you establish a position. So you hold 100 shares of XYZ in your account. Many of these clients are very savvy. They have strategies in place. They want to maximize their gain, minimize their losses, optimize their tax obligations. So that's where what we do is for each of these buys, we create lots so that when you're trying to sell them, you can pair them to manage the strategies that client has opted for. So if you have a highest gain on a particular position and you have a loss on another position, you try to match it because you want to minimize the taxes. That's what client told you. So that's where we create tax lots. And then around all this is product or securities. This is, IBM shares or municipal bond issued by Salt County. Those are the products. They form the basis of all this activity. When you buy a share, you need a product. So this product or security is data is also part of the building block. And then you get prices. So when you try to buy, let's say, share of XYZ at 10 o'clock in the morning, and the price is 20, that's the real-time price. So that's where you say, okay, buy, and then broker goes out, buys 100 shares for you of XYZ at the price of $20. So you have concept of price. These are real-time prices, and then also there is a concept of close of business price. And those prices are needed in order to, the next segue of this is derived data. What we do is we compute market value of an account. So in order to compute market value, what happens is there's a real-time market value, and then there's the end of day market value. Price and quantity gives you the market value of a position. You aggregate all those positions, add your balances, cash in, let's say, euro, GBP, whatever you have it, and then you come up with a market value of the account. Why do we do that? Because we want to see how the account has performed over a period of time. So my value of my account when I funded was $100 2 years ago. Last month, it was $120. At the beginning of this year, it was $150. So that allows us to track performance of the account. So my account had 20% inception to date last month in this example where my original market value was 100 and I was at 120 at the end of last month. So that's another derived attribute. And why do we calculate that? Because we want to show the client that we are working hard for them. And by investing their assets with us, we are able to get them better results than, let's say, S&P 500 or any other indexes that are out there that track the broader market performance. Another aspect is we want to show clients how their assets are distributed. Asset type, so you have 25% stock, 35% bond, 10% cash, all this asset distribution that you see, a pie chart, that also is derived out of this information. And then if you want to see what are the gains or losses on your account, starting from this year's, then you look at all the activity, what is your purchase price, what is your sale price, the difference is your gain loss. This is what is called as realized gain loss. If you want to look at a hypothetical scenario saying, I want to see if I sell this particular security, what will be my gain or loss? That's called unrealized gain loss because you haven't realized it yet. So all this derived data also comes from these building blocks. I'll take a pause. Any questions? Okay, I will continue on. So before I go into the challenging aspects, I just want to highlight that what I am going to talk about is specifically in the private wealth management space, because that's where I have worked, and that's what the stats that I'm going to present it to you. By no way this is what entire Goldman or financial industry goes with. Each of these divisions they have their own challenges. If you are a trading securities division in the firm, you deal with millions and millions of transactions a day. So you are dealing with a little bit of a different problem, and it might be n-fold larger than what I kind of showcase here. What I'm going to show is a sample data set that we deal with. I just wanted to pre-qualify that before we go into this. So what are the challenges? So in the systems that we deal with, you have hundreds of thousands of accounts. You have millions of positions. And on a daily basis, you're dealing with 350,000 to 400,000 transactions. So that's a typical day, and you're going to consume about 900,000 prices. Okay, that coupled with the velocity of data, and I'll go back to March where markets were volatile. As you know, financial industry does not like uncertainty. Whenever there are regional conflicts, any issues, and there are uncertainties, market tends to be volatile. So at that time, we see spikes. And in specifically for the management industry, there is another nuance of getting dividends, interest, coupons, around quarter end. So that's where we see significant swing in daily volume. And what I talk about, it's about 5 times the normal, 4 times the normal. That's the type of swing that we see. And to make matter worse, 60 to 70% of that peak volume comes in matter of hours, 3 to 4 hours. So not only you have to design your system to manage daily load, but you need to design your system in such a way that it can handle these peaks without impacting your other obligations. And that takes me into the next section. How do we manage that? So I want to pivot it into some of the strategies or structures that we use to manage this data. Obviously, live view, all these transactions are coming. You keep posting, update your balances, you see the live view. But we are always required to go back in time for a number of reasons. Let's say our statements that we produce, which is a legal document that we have to produce every month for our clients, that looks at balances at the beginning of the month, end of the month, all the activity that came within the month, and then tries to give some of this data. That process needs to look at data as of point in time. So what I mean by that, you are looking at data which is constantly churning, but at the same time, you'll have to go back in time and provide what the data was at that point in time. These are needed, as I said, for statements. There are also, sometimes there are regulatory requirements that we need to do something as of holders of this particular security on this date. There are times when there are regulatory queries saying, show me this data 5 years ago, how it was in such and such accounts or such and such products. So there are a number of use cases where we need to go back in time, but let's talk about how we achieve that. What I'm going to talk about is milestoning or temporal milestoning, which is putting data in one dimension. So imagine if you are keeping balances on a day-to-day basis for an account, for a position. So as of 9:30, your closing balance was 100 shares. As of October 5th, let's say you bought 200 shares of company XYZ, so your closing balance is 300 shares on that day. And if you look at it, I'm depicting them by 2 columns, period from, period to. This is where the one-dimensional view of data. On this day, for infinity, the balance was this. On this day, for infinity, the balance was this. How do we use this? So let's say if you want to go back in time and say, show me what your balances were as of 30th of September. What I will do is, in this milestone table, I will go back in time and say, show me anything that is infinity, which is less than October 1st or less than or equal to September 30th. So it will pick up this row, ID number 1, and you have quantity or position saying 100 shares, and then you can do whatever you want to say. You want to, create market value, multiply times by price. That's how your market value comes in. But that's how the data helps us to go back in time and figure out. Let's say I want to see what my positions were as of now. So you look at the infinity row. You look at saying, now I'm going to look at my infinity row and my quantity is 300, and then you can use that data into your computation. Now, this is a very simple one-dimensional view. Our systems are global data churns near real-time basis, and we have to keep our balances and ledgers up to date to make sure that we are able to move forward on a real-time basis. At the same time, go back in time. If we were to say, show me your positions at noon on September 30th, there is no way you can do that. So, excuse me. That's where what we do is we add another dimension, which is the time dimension. So in this example, let's say, the activity came in at 9:10, 100 by. My position is 100 after 9:10 a.m. On September 23rd onwards. Another buy came in, let's say at 1:05 p.m., 200 shares. So now my position is 300 shares starting 1:05 p.m. onwards. My current view always will show you, because this is my infinity row, this is my infinity value, it will always show you the current data. But if I want to show as of noon, what is my balance, or as of 10 a.m., what is my balance, I need to have another dimension. I put it in here as in version from, version 2. This is also, sometimes it's called snapshot to, snapshot from. There are a number of meanings to it, and you can Google it. This is there's a lot of information about temporal milestoning, and there's a lot of research, and there are a lot of other strategies to compress this data as well. But for the purpose of this discussion, let's just say we have a running tally of change in balances as and when the activity comes. And this is a synchronized data set. Basically, when you post an activity, your balance also gets updated in one transaction. It's atomic, it's ACID, so that you don't have any discrepancy. If transaction persists, your balances are also persisted. So now go back to this use case. I want to see what is my balance as of 10 a.m. So what I'm going to do is I'm going to find an infinity row at 10 a.m. On that day, on September 23rd, let's say, and this is the one. But if I'm looking for something at, let's say, 5 p.m., what is my balance? What I'm going to do is, if you look at it here, when the second activity came for September 23rd, I milestoned my first activity. I said from September 31st, 9:10 to 11 or to 1:05 p.m., this balance is 100. But from 1:05 p.m., 52 seconds, and trust me, they go into milliseconds. But for the sake of simplicity, I'm showing you this. The balances 300 shares for this particular product. So now if I want to go back in time and say, show me my balance as of noon, what I'm going to do is my version 2 is less than 10, noon. My date period from is 9/23. So this will put me into this category. So I'll pull out my balance as 100, and then I'll compute all the derived data set out of it. Let's say I want to see what is my balance at 2 p.m. What I'll do is my version from is, less than 2 p.m. and my date is this. And version 2 is also greater than 2 p.m. So that will qualify second row. That will put me, that will show that now I have 300 shares of XYZ. And you can imagine this happening across 10 plus million positions, 350,000 transactions or 400,000 transactions on a normal day or on a peak value. So you can see how much thought process goes into designing your applications to manage this. And in addition to that, imagine your data store is retaining data for 7 years, 10 years, 20 years. How do you manage this enormous data size? That is where there's a lot of thought process that goes into building data structure, building, if it is a relational database, building indexes. A different conversation, different day, but I just wanted to highlight the challenge that we are facing and how we are managing it. In the later sections, I'll talk about some of the technology aspects, and you will see this as well. So that's the other aspect, and I don't think this is unique to just to financial industry. I know healthcare also needs to retain data for X many years. I know insurance companies. I know other industries. I'm sure Amazon, you go, it shows you your order history for X many days. So it's not unique, and we are managing with it. The other aspect that to some extent is unique to financial industry and to some of the other industries as well, healthcare and insurance, to be a little bit more precise, is the data privacy. Lot of jurisdictions are putting emphasis on protecting client data, client specific details, name, their government identifiers, their gender, their address, all these things that is considered as private. There's a lot of emphasis, and there are a lot of regulations that have stemmed from it, which forces industry like ours to put in to comply with some of these regulations. GDPR, which stands for Good Data Protection Requirement. It's more of an EU regulation where we had to work with, we had to enhance many of our databases and storage strategies and how we send data out, how we display the data out, how we even access the data to comply with some of these regulations. Things that I'd like to highlight is encryption at rest of data. So all the data that resides on the disk needs to be encrypted. And that encryption algorithm, the keys needs to be rotated periodically and all that. So that's one aspect. Second aspect is data in transit. So if you are fetching a privacy data from one data store to another data store, showing it into your UIs, you need to build HTTPS or secured protocols that encrypt the data in transit. One of the other aspect is the data owners have rights, and this is where data subject rights come into play. As a data owner, as a client, I can ask the institution saying, hey, make sure my data is only visible to so and so or XYZ or only to this team or that team. And when I leave the firm, I could be asking as a client saying, make sure my data is destroyed. That's also built into the regulation. The other aspect comes in as part of this is we as technologists need to have control over what data we can see. So we have to build access control. Privacy information cannot be seen just by running simple SQLs or on the screens or what have you. We have to build processes that allow somebody to elevate themselves to these roles where they can see the data. And then we also have to build controls where somebody who elevated themselves, did that work, and demoted themselves, the manager or somebody goes and validates that, yes, that person has done what they said they were going to do. So there are post controls that we have to build, and these are the things that auditors look for when they audit highly private applications like private wealth management applications. I'll briefly touch over some of these two items. There are certain jurisdictions that restrict us to take data, their client data, out of their geographic boundaries. Now, we are a US regulated company. We have to show our quarterly reports and whatnot. We have to show how our assets and management are, which entity holds how many assets and all this other information. So what we have to work around is kind of obfuscate this data when the data leaves the perimeter of those jurisdictions or those countries, and completely anonymize it so that we honor those regulations as well. And the last thing is, with all this data channel, with all this, there are stringent regulatory requirements. There are SLAs that if you don't meet, you have financial and reputation impact. For example, if you're trading, you have to report your trading activity within 15 minutes to some of the regulatory boards. Like if you're doing a muni trade, you have to report it to MSRB within 15 minutes. There are tolerances. We have to do it by 85% on a given month or 90% on a given month. But again, we try to make sure that we meet or exceed those requirements. And that's where, if you think about it, trading applications, they have a very high bar when it comes to executing trades in split seconds or milliseconds. So I'll take a pause to see if you have any questions, if you want me to go over something before I move forward to the next segment. We are 30 minutes into this discussion. Okay. All right, so let's go into how we manage from a technology perspective. And I'm going to brush through this slide a little bit quickly because there are two other slides that show this data more in a pictorial way. So good old RDBMS relational databases. They're good for small to mid-sized databases. You're dealing with terabytes, 10 plus terabytes. They tend to be good. When you are getting into 100 plus database, terabyte space, you're looking into some of the columnar databases. They do well. Basically, these are relatively easy to implement, and you have to put in this milestoning algorithms because you can go and update data in place. There is nothing that it kind of archives or does this stitching for you. You'll have to put those you'll have to implement that programmatically or from an application standpoint. The next part, where we are going towards, is Lake, where Lake is the concept is data is immutable. Obviously, you have to design your data lake in such a way that you achieve that, but that's the underlying principle. So if you design it properly, if you have your primary keys defined properly, this is where it gives you out-of-box milestoning. And here you're leveraging power of MPP, massive parallel processing, where you have a lot of nodes talking to each other. Data is replicated on multiple nodes. So this whole ecosystem gives you some of these capabilities out of box. Obviously, you need to have scale to implement this, especially when you're getting into 100 plus terabytes. And then you want to have a centralized data store where you can put in a lot of controls. And I'll go into that in a little bit detail into the next slide. So traditional data management model, you have all your data blocks that I talked about, accounts, clients, positions, transactions, what have you. They go into their own databases or their own systems, and then from there, you put them into DataLake. I'm sorry, to a data warehouse. Concept of data warehouse has been around. Data warehouse has been built in, within divisions. Sometimes you have multiple data warehouses because you can't scale after a certain size of data. Obviously, relational databases performance starts degrading. So you have to build, within divisions. You might have seen multiple data warehouses. Across divisions, you have multiple data warehouses, and with that comes their inherent challenges as well. Like, let me finish this thought. Basically, all your um, you know data distribution, data consumers, they tend to connect to this data warehouse via UI. They directly query the database. You send it via application files, you create data files, and it is some other database where they load. So just because they cannot scale, and that's where some of the inherent challenges of maintaining data comes in. Now you have n copies of data, which at each of these databases are getting manipulated. So you have n, value n here. Now it becomes n prime. When it goes to a data warehouse 1, when it goes to another data warehouse 2, it becomes n prime prime. So the data transforms, because that's what we all do. We get the data and transform it into information, right? So it's very difficult to reconcile this data, because now you have to build n factorial reconciliation to make sure your data quality is in check, right? The reusability of code is also very little, because now you have same data replicated into 5 different databases, 5 different systems. They have their own ways of manipulating the data, because some needs 2 attributes, some needs 5 attributes, some needs 10 attributes. So everybody builds their ecosystem around their needs. There's no common interface, common infrastructure to help build reusability, right? And in all this, God help you to figure out how to validate and track your data. I mean, it's just going to be a very, very difficult exercise, right? So that's where our data lake comes in. So the concept remains the same. You have all these data sources, accounts, positions, transactions, all the external files, prices you are getting, a vendor is sending you prices that you're loading those as well, right? So that you can still use that, but you can build a common interface, common ingest. So what happens is you hydrate all this data into the lake, then you build a common interface that looks for change in data. So there are strategies to get that. You keep looking for certain key attributes or primary keys to the data source, and you keep gathering this change in data. That's what this common interface helps you to ingest change data sets into the lake. What you do with it is all you from a business requirements perspective. This chair is getting in trouble. From a business requirements perspective, you have your refiners, you persist the data into another data store, or you show it through some other in-memory data store. You can do a number of things with it. But the value is, or at least the point that I'm going to talk about here, is how you render the data. You can build a common interface. Now, that interface is going to expose, not for one consumer, it's going to expose a data set, price, position, transaction, all those things by connecting to this data stores. What do we achieve by that? Because now you have one interface that you can leverage. You have let's say you have 10 consumers in a traditional model. Let's say there are 10 consumers going, or let's say 50 consumers going into 5 different databases. So you have 10 consumers per database, and they're looking for 1, 2 attributes, another 5 attributes, another 10 attributes. So all these 5 data stores, or in a traditional data model, they were exposing those attributes only, or they were consuming those attributes only because that's what they're interested in. and they were exposing it to their consumer. And when they need one more attribute, they're allowed to come to you. You add it. They have to add it into their rendering mechanism, and then they expose it to that. Versus here, by having a generic interface, you expose all 15 attributes. Consumers can decide what they want. This is where the new contracts are evolving, right? You, as a data producer, I expose all the data. As a consumer, you decide what you want to do. What it helps me is now, when I build an interface, I don't have to cater it to 1 or 2 or 10 customers. I'm catering it to everybody. And then when there's a need to expose additional elements, most likely most of those consumers are interested in that. Or even if they are not, today, down the line, they might be interested in it, and it's already there, right? So that's what you achieve by putting a common interface. Now, there are things to consider when you have a common interface. You need to make sure that it's scalable. If you think about it, in a traditional model, 5 databases, 50 consumers, so 10 consumers each, you only have to scale to 10 consumers. But in this model, you have 50 consumers who's making the same call, because from a producer perspective, you have one interface. So you need to make sure that you have scalability. You have room to expand, because today you have 50, you might grow to 500. So you need to scale horizontally, you need to scale vertically, and you need to build those capabilities into the system. So we talked about generic API. Another big advantage of this is you can build data validation centralized, because everybody's coming to one place to fetch the data. You can put a lot more controls, and you can have a lot more validation, and you have a lot more confidence in the data, right? So these are some of the few advantages. There are a lot of them. We can go into details if time permits. But I'm going to move on to the final slide, which is these are the technologies we use. And if you are interested, if you enjoy doing some of these things, if you want to learn how we build to the scale, please, 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 we want to hear from you. Reach out to us, reach out to me, anybody. We would like to talk to you. And then before I go into Q&A, one last point. I would appreciate any feedback you have that will help me make better and do this kind of engagements better in the future. So I'll open up for Q&A. Any question from the audience? Zach, any questions on any of those channels? Zach, you're on mute.
Can you hear me, Dhimant?
Yes, I can.
Okay. Yeah, we have there's a question. What is the split between structured and unstructured data?
So a lot of our data is structured, but we do have unstructured data as well. Like you look at transactions as trailers in them, and I don't know how familiar you are with, but if you, let's say, go to your credit card and you do a transaction, you see in your statement that says purchased from this vendor this much amount. So there is a fair bit of unstructured data, but I would say a lot of our data is structured. I don't have the split. I can I think I don't have that from top of my mind, but we do have a variety of data. We do have structured versus non-structured data. The data sets that I talked about, a lot of them are structured, but we do have within those data sets, there are attributes that that are unstructured, and then we tend to make sure that we are able to handle them in our data model.
Okay, follow
Hope
up
I was able
question.
to answer the question, or at least try to answer the question.
Yep, there's a follow up there. So specifically in your data lake, are things like data files versus SQL database structured or unstructured?
So the question is that within Lake, do we have structured or unstructured data?
Yeah.
The answer to that is yes. We do have both structured and unstructured data.
I had another question. It's actually my own question. What layer or layers is the retention for regulatory purposes happening at? Is that at the lake level or multiple levels? I guess where is all the backups happening
for
retention?
Sure. So the backups are happening. It's a very good question, actually. That also is, I couldn't go into the detail, some of the challenge, parts back. But we are required to have backups of our data. We do have multiple types of backup. What we have is we take point-in-time snapshots as well, as in that allows us. So we have a daily backup and number in the morning or evening, depending on when the system is least used or, there are free cycles. And then we also have point-in-time backup. So you have a backup, let's say from 5 a.m. in the morning after our batch completes, and then you want, you open up for processing, and then something happens at noon. Let's say there is a corruption, data corruption. It's a fact of life. They do happen. So you have to recover, data as of 10:45 or 10:50 a.m. So what we do is we take the backup that is taken in the morning, and then we keep applying incremental backups. It depends on the size of the log that we accumulate, but every 3 to 5 minutes, there's a backup file generated, which is a delta file from the 5 a.m. backup. And we keep applying it so that we can recover data at point in time. That's the database backup. There is also tape backup, where we tape. The database backup creates the files, and those files get backed up to the tape as well on a delta basis, on a every day versus a weekly. We have a full backup in the system. And Zach, that's a very good point. I want to take this time also to answer question that previously asked regarding unstructured data. So we do have data stores for unstructured data. We use Mongo. We have, we are storing some of the configurations, storing some of the trading related attributes, storing, as I said, transactional free-form tags. So they are also stored in there's an ecosystem for that, and we use Mongo. They're stored in that. And coming back to you, Zach, so I hope I answered your question from a backup perspective. There are multiple levels of backup.
That makes sense. We do have another question that came in. This question is DataLake recommended for near real-time operations?
Well, we do use DataLake for near real-time operations. It all depends on how you structure your data, and you have to be careful how much data you ingest and how much data you process. So delta ingest, frequent delta ingest, and frequent delta process. We have seen that gives us the advantage of keeping things near real time, versus we also have large index for our batches. What we do is we do ingest data in chunks and then process them um, on their own, where the data is not needed near real time versus where you have a few hours to process. So we have both strategies employed in our data.
Very cool. I'll pause right there and see if there's any other questions that come in. All right, I'm not seeing any. Thank you very much for the presentation, Dhimant. Thank you everyone for joining. I hope you enjoyed this session and the rest of the sessions today. Thank you, everyone.
Thank you, folks. Please don't forget to leave me for some feedback. Thank you.